So we are going to work on the following problem, which, as you can tell, x, y terms were mixed together. So when you find the derivative, it's going to be implicit differentiation. So you take the derivative on both sides simultaneously, decide which root to use. 3 takes derivative is 0, 2x plus derivative is 2. So the challenging part is how to differentiate the right side, which is sine of xy squared takes derivative. Well, it's quite intuitive that it's a composite function. The outside layer is sine x, and then your inside layer is xy squared. So when you try to use the chain rule, you differentiate outside layer, you end up with cosine of something, and then you squeeze in the inside layer, and then you take derivative of the inside layer. So you have 2 equals cosine of xy squared. This is a multiplication of two terms, so when you take derivative of that, you want to go with product rule, so you end up with structure like this. That is to say, it's cosine of xy squared times 1 times y squared times x times y squared takes derivative. Y squared, it's an elementary function of y. You imagine it as x squared, the derivative is 2x. You convert everything back, and don't forget you multiply your y prime to it. So it's x2y and y prime. So if you look at the structure, you realize there's only one term that's y prime related. So you want to single it out on one side and everything on the other side. But fortunately or unfortunately, it's inside the parentheses, so you can't just move it around as you wish. So you are going to distribute the coefficient term outside before you can have the freedom of shuffling things around. So cosine xy squared times y squared plus cosine of xy squared times 2xy times y prime. Now this is the only term with y prime, so you're going to move it to the other side. That is to say 2 minus cosine of xy squared. Y squared is cosine of xy squared times 2xy times y prime. So all you need to do now is get rid of the coefficient so you can reconstruct your y prime. So you have your numerator here, which was the original left-hand side, and then you divide it by the coefficient on the right-hand side. So you could now get your final answer, which is the expression that looks like this.